Right now, try again.
Thanks, YouTube.
I'm gonna need you. This happened last week. Oh, there it goes. I think.
Thanks,
Would
Melissa.
you like to? Thank you, Melissa. We really appreciate you helping us out there. Can you check your tab as well and see if it's going in?
Let's see.
Go ahead and go to edit video. I think it might be doing it now. Nah,
It says live.
Okay, it says live.
Thumbnail updated.
Yeah, I just need you to go into the live dashboard. Yeah. Nope, not that one. The yep, that the little icon there. That'll load it up. I'll destroy the instance. Okay, so it is streaming. Okay, cool, excellent. Well, welcome to the show. We just started our housekeeping stuff, and we're hanging out in the Discord chat room, and yeah, we're just making sure everything is streaming out there. So thanks for bearing with us.
Go ahead and jump into this week's project.
This week's project is a very fun one, and we're still working on it, and we hope to release it later today or tomorrow. But we do have a video that's going to explain what it is and some really fun shots of it in action. So without further ado, let's go ahead and play that video. Yeah?
Yeah. Go.
Okay. All right. Here we go. We'll see you on the other end. It's only like 2 minutes long. And go. Wait, that's not it. That's the
live feed.
That's the live feed. All right, I think it's this button. Are you guys ready? Here we go. Hey, what's up, folks? In this project, we're building a scoreboard using an LED matrix and CircuitPython. We thought it'd be cool to build an indoor game where you can shoot some hoops and show your score. So we built an IR sensing hoop that displays your score on an LED matrix. We 3D printed the parts and designed this to be an easy build so folks can make one at home. This uses an IR brake beam sensor to detect when the ball goes through the hoop. The IR sensors are secured to the 3D printed hoop with the wiring hidden inside. There's an arcade button on the side that's used for starting a new game and resetting the score. This whole build is powered by an Adafruit Feather M4 Express and the RGB Matrix FeatherWing. The code for this project was written in CircuitPython by Liz Clark. On startup, a bitmap gets displayed and checks if the arcade button has been pressed. When the button is pressed, a new game starts and shows the scoreboard. Each time the IR sensor detects break, the score increases by 2 and plays an MP3. If the button is pressed while playing a game, the score is reset and goes back to start. All of the code, images, and audio files live on the device like a USB drive, so it's easy to change and modify. CircuitPython makes it easy to code hardware so you can build fun and interesting projects. This build features mounting holes so you can attach this to a frame or tabletop. The Matrix FeatherWing and Feather M4 Express are snap-fitted on the back of the display. A STEMMA speaker is also on the back and plays audio files when you score points. Be sure to check out the Learn guide for a full step-by-step tutorial on building this project. We hope this inspires you to build projects with CircuitPython so you can enjoy your time indoors. Thanks so much for watching, and be sure to subscribe for more projects from Adafruit. Alrighty, so that is the video. All right, thank you for watching that. Yeah, so that's this week's project. Again, the Learn guide is still cooking, and we are...
I'm actually going to take a little quick preview of it while
Yeah.
it's in progress.
Yeah,
Got a bunch
we'll
of
run
pages
through it.
done, so we'll go ahead and check out a lot of the assembly and build.
And code. All right, so yep, this is the Learn guide that's in progress. We still got some images and things to make. It's very similar to the slot machine project, as it's using the exact same matrix display. This is the 64 by 32 matrix, and we're also using the Matrix FeatherWing, which really makes it simple to attach any feather to the back of the display. The display itself is indeed in stock, and the price is looking pretty good. So check that out. This is the 4mm pitch version. Again, the 64 by 32. And let's go back into the Learn Guide. We're using a sheet of black LED acrylic, similar to the slot machine project. And we have some sizes here, so you can get that pre-cut from Tap Plastics, who is the folks that are cutting it and distributing it. So you can purchase it from them. And this is the size that we used for our particular matrix.
You can get this yourself, but it is a little difficult.
I think it's easier. Yeah.
I think it's easier to just have them.
Yeah, I definitely would. Yeah, even, yep. There are a handful of screws and things. I have them listed here. But as for the main brains of the operation, it is the Feather M4 Express and, again, the Matrix FeatherWing, which are both in stock.
Oh, wow. Melissa is saying that they used to be $65, so yeah, that's a good price.
I actually have a story. Somebody, yeah, it used to be $80.
Oh, wow.
Yeah, and yeah, it's like half the price now, which is great for folks that want to pick one up. Now it's a good time to get it, as the price is about half now, which is really nice. For audio, playing MP3s is a fairly new addition to CircuitPython, and one of the easiest ways to get speaker output from a Feather is with a STEMMA speaker. This has an onboard amplifier, and it has a little mini oval speaker attached right to it. And you have a STEMMA connector and some pads here if you want to do some alligator clips. Here in the photo, it's attached to a Circuit Playground, but you can attach it to just about anything, which is nice. It's got an arcade button for the reset and starting the game. The IR sensors come in 2 different sizes, but they have the same sort of dimensions, like product dimensions. The hoop it will fit both of them, as they have the same body. The only difference here is this version is using a 3mm LED, and the other version is using a 5mm LED. I'm not sure if there's, I don't know the particular difference between the two, other than the LED is bigger on one. So yeah, I'm using the 3mm version, but I'm sure the 5mm version work as well. An assortment of JST connectors, as these are used to kind of help make the connections easier and the wiring management is a little bit easier. So you can disconnect components and reroute them if you need to. So that's why I have them listed. I like to use silicone ribbon cables, so I got those there. You are going to need some female headers. Now the RGB Matrix FeatherWing does come with some headers, but we're going to use some female headers in this version, and those do not come with it, so that's why I have them listed here. And it's always handy to have the M25 kit that we offer, as it has an assortment of standoffs and long screws that we'll use to secure the components to the parts. Okay, that's kind of the introduction. The circuit diagram just shows you a visual representation of the wired connections. We got our button, our IR receiver, transmitter, and our STEMMA speaker. We are kind of using connections from both PCBs. The Feather M4 has a nice assortment of ground and voltage pins, so we're able to just use all of those, so we don't have to share the voltage and ground pins, which is nice. And then the FeatherWing itself has an extra row broken out for the 12-pin and the 16-pin sides, so that you can have access to them. And we are using a couple of the pins. The button is like D4, A0 for the STEMMA speaker, and A1 for the IR sensor. We had to be really careful with these pins in terms of just picking the pins, because the RGB display kind of uses all of them, to the point where I don't think we could have used. We were thinking about making this like IoT connected, and then we just came to the conclusion that like, yeah, maybe not. So, but maybe that needs some further exploring. When it comes to powering this thing, the display does need external power from a wall adapter, and what we recommend is the 5-volt, 4-amp power supply. You really, really want to be careful with this. I hate to admit, but hey, I accidentally plugged in a display. I plugged in a 12-volt power supply to my display, and I fried it. Thankfully, the FeatherWing and the Feather M4 did not fry, but the display basically was cooked So please be careful with that. I should probably put a little note here saying that, but I mean, yeah, it's very embarrassing. So don't do that, man. I could, anyway, I have excuses. I have plenty of those. The 3D printing page needs a lot of love, folks. So what I'm going to do is I'm going to show you the CAD design and just kind of walk through it a little bit. How are we on time? We're okay?
Yeah.
I'll spend maybe 5 minutes or so chatting about that. Let's see if I can get a full screen here. All right, so I mean, it's worth noting that the display, there sort of was 2 versions of it, and we do have models of both versions, though it's going to be hard to kind of know which one other than to visually inspect where your mounting holes are. So I did have to make 2 versions of this. So what we have here is these corner brackets, and they are using the 4 mounting holes on each end here on the back of the display. There are 4 mounting holes. There's actually 6, and we're using all of them. So there's that. Another added thing that the corner brackets have are these little slots that allow the sheet of acrylic to kind of be pressed up against the surface of the display so that it can diffuse those LEDs. There's some extra holes here on the side of the corner mounts that have an extra bracket. This is how the arcade button is mounted to the side, is with an extra mounting plate dedicated for the arcade button. And then we have these 2 mounting feet, is what we'll call them. And those have these little tabs on the side. And they are mirrored, so you want to print each one of these out. And they will be oriented for you to print, because you do have to orient them kind of like this in order for them to print. Let's see what else. The STEMMA speaker itself is mounted to the speaker plate, and then that speaker plate is mounted to the 2 holes in the center of the display. So that's working. The hoop itself is parametric, which is really, really good because I really wanted to make a fairly large hoop. So, golly, I forgot. I think it's like 204 millimeters. What is 204 millimeters in inches? That is about an 8-inch diameter hoop. So I figured that's a pretty standard hoop for the mini style hoops. So I wanted to be kind of consistent with that. However, that's going to require a fairly large build plate, and I would like this to fit printers like the Ultimakers and the Prusa i3 printers. So what I can do is I'll bounce out some pre-sized hoops. So I'll have one that's like 190 millimeters, maybe even 180 millimeters, and I'll have those exported as STL so folks can print those. That will fit hopefully a wide range of printers. But if you do have, like, let's say a Creality CR10 where it has like a 10 by 10 inch build plate, you should be able to fit that no problem.
I think it's 12 by 12.
Or 12 by 12, whichever one. The hoop has some channels here for threading the wiring from the IR brake beam sensor. And the brake beam sensor there's a receiver and the transmitter. And they both are kind of press-fitted into these recesses here. And then there is a single screw, an M25 screw, that will secure the body of the IR sensor to the hoop itself. And you can see that all these little channels here are going to help you route that wiring through the hoop so that it stays away from the shots when you're making your hoops. There is some mounting tabs in the back here that will attach to the hoop brackets, which gets secured to the feet here. So all these little pieces all kind of fit together to make this work. And hopefully if I explain that, I'll be sure to upload and export this whole assembly so folks can have the entire thing. Yeah. Any questions or anything about the design?
Just in the Discord, we got some nice discussion on some of the previous pricing for the Matrix.
Yeah.
And Maker Melissa was able to find her old receipt on that. So you can see that, yeah, the price drop.
Yep.
It's nice.
Yeah, it's great. I think we found some suppliers that were offering it with better margins or something, so.
Yeah, I'm just posting the link to the Fusion 360 file so people can print this out.
Right. And
Yeah, we'll do some more documentation in the Learn guide that will help you better determine which version of Matrix C do you have. I took some pictures of them both. I just don't have them here, so I can show it to you. But I do have them. I can actually open that second design and share just how different the kind of mounting holes are. So this is the kind of first Matrix. So if you bought a Matrix a couple months ago, or maybe even a month ago, you might have this version. You can see here the mounting holes are not going down the center, but more offset to the left and the right side. And then the corner brackets, because of how offset those mounting holes are, the corner brackets have not a vastly different design, but enough to be like, yeah, that looks completely different. But we are kind of using the same style of feet and brackets, and the hoop is the same. I needed to make sure that the hoop and the button bracket and the hoop brackets are fairly the same, so I'm trying to have some consistency here across those two designs. So that was a little bit of extra work, but hey, I think it's worth having both of them because I did have both of them. So I was able to measure them out and make sure that they all fit nicely. So yeah, there's a little bit of insight in the CAD stuff. Cools.
And then Mark was asking, is there anything special so that the hoop bends and does not snap, or is it just a really like small basketball?
Yes, definitely good. How much stress can it take? It really depends on the material. I would highly recommend using some PETG material, as it's a little bit better in terms of flexibility and strength when it comes to like PLA. I have, however, used PLA, and I also would recommend increasing your shell count to 3 or maybe even 4, and your infill to at least 10%. So yes, I tested it several times and I broke 2 of them, and that is because I just didn't have enough infill and I had some pretty low shell counts. So I've been stress testing this one quite a bit. We'll go back to it and kind of show how it flexes and things. But yeah, that is definitely a consideration. You don't want to put too much weight on it, as it can definitely snap. But I don't have any PETG material to, unfortunately I don't have any PETG material on hand, so I haven't used that in this project, but we definitely should.
It's definitely one of those maker lottery things where the design of it, the way that the mounting parts for it just have enough give so it bends instead of breaking.
Right. But yes, it has broken, and that was partly because I just wanted to print it quickly, so I didn't put enough infill, and it did snap. And I'll show you guys where it actually snaps, or at least it snapped pretty consistently right here, right around this area here in these tabs. So they're fairly thick, but even still, with too much force, it will definitely snap. But that seems to be where the weak point is, around here. So having extra shell count and more infill will definitely yield a stronger part. Yeah, I'm glad somebody asked that, because it kind of escaped me for a second, because I've been playing it for so long and kind of forgot that, yeah, it did break earlier in the prototyping phase. Cool. And those are all the pieces. They all fit in the shot, which was nice, because they're fairly large pieces. But it's modular. When the hoop broke, I didn't have to reprint all the pieces, because it was just the hoop piece. But unfortunately, the hoop piece is kind of the biggest piece, and it takes the longest, clocking in around 3 hours to 4 hours, depending on your speed settings. But yeah, that took a bit. Cool. Another thing that's worth noting, okay, let's jump out of CAD stuff and kind of go back into this here. So this is it set up on our table here. This is just a little kind of podium table that can be raised and lowered. There are some tabs on the feet. I can't quite show it to you, but the way we're having it secured to this tabletop is with mounting tack. So mounting tack is this sticky stuff that doesn't leave any residue, and it can be reused quite a bit. So we tend to use it for temporarily securing things together. Ideally, I would want to screw this into some sort of piece of wood base, a wooden base, so that I can attach that to a frame or something of that. Maybe put some weights on that wood. But here you can see The screws are slotted back here, up here, and then mirrored over here. So you have 4 mounting holes that you can use, and there should be enough clearances to get a drill in there if you're going to drill it into something. But yeah, that's how I have it set up here with this mounting tack. And then I just press it down, and hopefully that stays there. Okay. So yeah, you use the arcade button to start the game, and then the hoop is now ready and willing to start taking some shots. So it's going to be hard to demo this, like, you know, because it's all the stuff is here, but there it is working. The sound effects are really nice. They're MP3s. It's using the new MP3 library by Jeff Epler. Shout out to Jeff Epler for helping us get this in a state where it's not crashing. It's a fairly new library, and you just got to use it so folks can start playing MP3s in their projects, which is really nice because the file sizes are small.
So we got Sebastian Perez in the YouTube chat asking the name of the sticky stuff. It's called TAC, T-A-C.
Is it? It comes in different colors, and different folks make it. 3M makes it. Who else makes it? You can get it from the dollar store, Amazon. And yeah, we heard about it like a decade ago. Like, folks were, like, wedding photographers use it to hold up rings, and they liked it because it doesn't leave any residue behind those pretty surfaces. So that's how they're able to get those wedding ring shots. They prop up their wedding rings with tack.
And then Andy Calloway saying blue tack, it also goes by.
Blue tack, yes.
B-L-U-T-A-K. And like you were saying, it's available everywhere, like dollar stores,
your
grocery
local
stores,
hardware store, whatever. So yeah, this is the build.
Yeah, what's really cool about this is that it's pretty modular, so you can use this if you don't want to have it as a game. You can have it setting up as, you know, how many people are leaving this room or how many people are opening up the fridge.
Oh,
so it is a nice little way to count things like just traveling through.
Right. You know what I just thought of is tiny whoop drones. You got yourself a little drone thing.
Yeah.
Those little obstacle courses for FPV drones. Wow, that'd be cool. If you're not into the whole sports ball thing. Perhaps soccer or something, another football.
Yeah, wherever you could mount the beams to break is a nice way to keep track
Originally,
of that.
the thought was to put this on the rim of like a trash bin, like this. But that it's just a little bit more complicated to do that.
Yeah,
so I figured I'd have it all, and have to route some longer wires and things. So I figured I'd have it all contained into the display itself. Now there is some cautionary warnings that you are throwing a ball at a display, and you know, you got to be careful. Even though I just did that, you can see it's still going and it didn't flicker.
Yeah, it's surprising really nice how well that tack is able to hold on to there.
I mean, this is a rubber ball and all, but still, you're hitting. It's a backboard, right? So, oh, that's a fun one. You'll get more points if you kind of get this kind of swooshy rim thing, where it kind of rolls around the rim. It'll just keep. It's a good way to kind of rack up your points. But yeah, the delay is quite quick. You can just kind of see how fast it's iterating through the scores just by holding it, breaking the beam.
And we got Yanni in the chat room saying that some NeoPixels for the rim would be totally awesome.
Yeah, we actually have a guide in the Learn system that has a similar project. It's an Arduino. But yeah, that could be a fun one. Yeah, I think that'd be cool. Maybe for V2. So the display is using Display I/O, and this is a custom font. So you can completely create your own fonts for the display, which is really cool. Liz put that together. She also put together the color scheme, which I'm always a fan of, and the graphics again. So if we want to like kind of reset and start over, just hit the button again, and it'll display that startup graphic. This is just a bitmap. So the bitmap is 64 by 32 pixels, and you can change it. All the sound effects can be changed as well. So if you want to like have some people cheering or you know, bottles breaking or something, you can completely change the MP3s just by swapping them out, which is really nice. Yeah. I guess let's take a look at the rest of the Learn Guide or take any questions.
More comments. Mark in the Discord is saying magnets to mount it to my office filing cabinet would be great, or would work great.
Yeah, there would have to be some strong magnets because the weight of the display isn't too bad, but
oh yeah.
I
mean,
curious,
you could separate the display, have that mounted on top of the file cabinet, and then have the hoop is what's actually on the magnet.
Yeah,
on the file cabinet side.
I did think about using like slotted aluminum brackets, like our 2020 aluminum extrusions, because I've created like a little over-the-door hanger for them, and I figured, oh, that'd be neat to have it hanging over the door, though there's some wiring issues where you're just going to have some wires either go down or up into the ceiling or something, depending on how much you want to, let's say how... the word's escaping me. How complex you want it? No. How much effort do you want to put into kind of mounting it in a spot that you'd like? Go for it, though. I think there's a lot of opportunity for mounting in different spots and things.
Yeah, all right. Let's continue on with the guide.
Cool.
I think we're in the code section now.
Yeah, we're going to jump into the code section. So there's a couple pages of code. We want to make sure folks are able to update their Feather board with the latest version of CircuitPython. So this will just kind of walk you through that. There's some nice screenshots and things, and very thorough wording on how to get the latest version of CircuitPython in your board, as it is dependent on display I/O and the MP3 library, which is baked into the core of CircuitPython 5.3, I believe. Yeah. Okay. The scoreboard uses a handful of libraries. We're using the bitmap font, display shapes, display text, and the image load libraries. They're all listed here, and there's also a screenshot on the individual libraries that you'll need. You can download the library bundle and then unzip that folder and then just pick the individual libraries and referencing this list here, and then just drag them onto your CircuitPy drive once your version is set up with the latest version. Scoreboard code walkthrough. Shout out to Liz Clark for putting this together. She did an excellent job on documenting it and just making it robust code. So it just walks you through the setup in the intro here. This is how you set up a matrix display using CircuitPython and the RGB Matrix library. We're setting up some groups and things for our startup graphic, so that walks you through that. Here's all this text stuff. So if you're not a fan of the font, you can totally change the font by generating your own. We have documentation on how to do that. I'll probably add that as a prerequisite guide, just so folks know that they have that option. You can change the colors as well here using RGB values or some hex code. So we got the pink and the yellow here. The labeling here is going to help set the text in the positions. So you have an X and Y coordinate here, and then we have a rectangle here that is making our yellow and pink outline. Excellent. Some more setup stuff here as we are creating the bitmap using image load, and we're creating some more groups here. This is where we're starting to label out our pins for the brake beam, the button, and the speaker. So if you'd like to use different pins, you can, but that's what we have it coded here for A1 for the brake beam, and D4 for the button, and A0 for the speaker. For MP3 decoding, you want to set it up before the loop. This will help save memory when you're playing multiple MP3 files. And yeah, you just want to follow that through. There's some more stuff here that sets up the state machines. So you can check when the button is being pressed or not. In the while loop here is when you're checking if the button is pressed or not. And if the game hasn't started and you press the button, then it'll reset the score. Cool. Follow through it and you'll see all the different stuff. There is some neat kind of things here that the text will get some formatting depending on where the digits are so that it's centered with the display, which is pretty neat. So if you're wondering what that's doing, that's how you can do that. And then the last part is, yeah, I already kind of explained it. If the game is in progress and you press the button, it changes the hoop state to false and ends the game, and then it resets the score to 0. So there you go. There's more details in there, but I think just kind of quick overview is fair. Again, shout out to Liz for putting that together. All right, and the rest of it's like assembling it. So just walking through some build photos of wiring this thing up. Kind of need some lengthy wires for the IR receiver, and then all the holes here are sized for the various different screws. Yeah, and I'm just walking through wiring it all and getting all those JC connectors so that it's easily assembly to just plug everything together once it's all wired up.
Look at the parts list here. There's a 5mm and a 3mm LED IR brake beam.
That's right.
This is the 5?
This is the 3.
3. Okay.
Yeah, I think the 5 is the same. I think maybe it has a wider spread. I don't know. I should really look into that, but I think you're going to get the same result. Because I can see if you get a side shot here and your elements, if your item is too small, you're not going to hit that brake, so it has to kind of be in the center. So maybe the 5mm has a wider spread, I think, maybe. I don't know. Yeah. Okay, just some notes here on setting up the FeatherWing and the feather itself. Pretty standard. The feather snaps on top of the RGB Matrix FeatherWing. We got an assortment of cables here, and then we just kind of wire them through. We're using all the power and ground add-ons or pins that are on the M4 Express, which is nice. So we can power all the things there without having to share any connections. And then there's all those extra pins that we're using on the bottom of the RGB Matrix FeatherWing. So that's how we're setting it up. A lot of my projects tend to look like this, where there's a feather wing, and then all these like if you were to rip a brain out of a skull, and it would have all these wires. Sorry. And then the last page is the assembling the matrix. You got your corner mounts. You got some hex nuts. This is where you would install the black LED matrix, the black LED acrylic. You got your feet. You're securing those to the back there. You got your arcade button. That also has a JC connector. That gets panel mounted to the button mounting plate. That gets secured to the side. It's symmetrical design, so you can choose whether you want it on the left side or the right side, which is nice. That's a great feature to have. If you stick with symmetry, you have options. Yeah, it's panel mounted. Brackets get snapped on, and they get secured with the M3 hex nut and screws. The majority of the build is just M3 screws and a few of the M25 screws. The M25 screws are used to secure the IR sensor, the transmitter, and the receiver. And then the M3 screws for the rest of the parts that are assembled. The STEMMA speaker has mounting holes that are sized for M25 screws, so that's why I'm using M25 screws there. Just 4 of those longer ones, the 10mm long ones, some hex nuts to secure it to this little speaker mounting plate that has built-in standoffs, so that's nice. And that's sized to fit in the back there in the middle of the mounting holes on the back of the display. Plug everything in. The final build. And then the warning, take caution, you're throwing a ball at a display.
The acrylic does help a little bit, but yeah.
It kind of does. It
totally
totally
throw
does.
metal stuff at it.
Yeah.
This was originally intended to be like a waste bin.
Yes.
Like to throw things, like all your failed 3D printed parts to throw into.
Right. But that could, tip over easily.
Yeah, or scratch the acrylic.
Right. So, well, that was a good one.
And then SM John was asking, does the GFX library support animations or GIFs?
The GFX library, like the Arduino library, I'm unsure. But I believe that's an Arduino library, the GFX library for displays. This is using the display I/O libraries. And there's like a handful of those. You have display text, display shapes, image load for loading bitmaps. So all those are quite easy to work with, and they're documented nicely too. And this is all CircuitPython.
Going through the comments here. All right, I think that is it.
Cool. Let's head back over here. We'll do some more hoops tonight on the show and tell. So hopefully we don't break the hoop by then.
Start a new print now.
Yeah, I probably should. It's quite nice though, and the flexibility of it, the way it springs without a spring.
Melissa is saying for their Arduino and GIFs, might want to take a look at the Adafruit Arcada GIF decoder library.
Yeah,
got a couple projects on that.
Yeah, so that's right. Yeah, there's a handful of projects that use the GIF decoder. One of them is a really fun
a little crank.
A little crank. We are cranking a cranked powered GIF player using PyPortal. I think that's what it was. Excellent. Right. Well, if you would like, we would really appreciate it if you guys put an order in for your for your stuff. So again, we got some stuff in stock. We got that Matrix display, which is half price now. The RGB Matrix FeatherWing, which makes it really easy to plug in a feather into the back of these things, as they have these built-in IDC header boxes, sockets. So you can have your fun with those. I believe the M4 Express is also in stock. Feather M4. Yes, it is indeed in stock. And I would get it without the headers because, without loose headers so that you can solder them how you like. It's basically going to be soldered like this, though, as the feather is going to snap on top of that feather wing. And then the RGB matrix is pretty much set up like where's the photo of it? Like, somewhere. I'm in the wrong page. Anyway. Yeah. Okay, that was that. Okay, are we ready for Shop Talks?
Yeah, let's go ahead and jump into Shop Talk.
I don't know what we're doing, so Pedro gets to tell me.
Yeah, so last week we were talking about this new little camera that I got, the Insta360 R1 inch. And one of the complaints that we always have with these cameras is, man, they always over-engineer, under-engineer the cases that are included with them. I say under-engineer because this case doesn't fit this lens that they ship the camera with. You have to actually take this off, which doesn't make sense when you're on the go trying to film something really quick. So of course we designed our own. We have a 3D printed one in Ninja Flex here. So we have this very nice purple, and I attached the 3/8 inch adapter that we have here with a 20-20 to go onto this just little handle to hold onto it.
Selfie stick.
Yeah, a little selfie stick. So it is nice and rubbery.
Great use of TPU, or Ninja Flex, as we like to call it. Any TPU will kind of work. This is, I think, from SandSmart, which is a brand out there that has some low-cost filament. And this is some 1.75 diameter filament, and we printed it on our CR10S. What?
That's right.
Pro?
Unmodified Bowden.
Bowden
extruder. Yeah, so it's not the softest Ninja Flex. It is the short hardness for it is the 95A. So I also made a little bumper for the lens.
Yeah.
And then just wanted to show that, these camera guys always get this horribly wrong with making such a bulky case. It doesn't even fit.
That the folks that designed this case was for sort of a different iteration of this camera. There is a version of it.
This was included with the camera.
That's funny. Maybe they just
and then the way that you take this off, there's all this
nice,
stuff
but
in there.
There's a lot of extra stuff here.
It's why do you need to do this?
Yeah, the way it's kind of over-engineered. It's kind of nice. But this simplifies it to where you could literally just slip it out, slip it back in. It's still secured. And you give access to the two buttons on the top there. So there's a good look at some overhang geometry there. If you could hold that, I can adjust the focus.
And there's a little fillet on the bottom here to sort of hug the bottom where the battery is there too.
That's better. Yeah, and you can see the surface quality there. It looks, what do you call it? Kind of interesting texture. A little
under extruded because I used a 0.3 millimeter extrusion on that just to get that texture.
It's pretty good. I'm trying to rip it apart.
Yeah,
you can kind of see some under.
You can see the under extrusion on it, but that's actually the look that I was going for, just to get that textury feel onto it. When I extruded it at 0.4, it came out glossy and like the texture on it was nice and smooth, but it's actually it's something I don't want. I don't want to set down the camera and have it slip. I wanted that nice grippy texture. And then the other thing I found too on Thingiverse was this excellent design.
Oh, look at this.
This PLA design.
Okay,
it has this nice little hinge that allows it to go on a lot more easier.
Right, this is actually kind of neat. I like that. And then there's a slot here with some recesses for a screw.
Your GoPro knuckle to that.
Right.
So just to show that there's always really good designs on Thingiverse, or you can just make your own to make.
I really like this one.
It's a lot more better than what the manufacturer usually ships with it.
I mean,
and I thought it was just GoPro, because every single GoPro that we've gotten for the past couple years, we always have to redesign or design a case for it for our use. One that had the quarter 20 attached to it. And yeah, the same deal with the Instafolks. Sure. And what's really cool about this one is just using a little piece of filament to act as the hinge, or the pin for the hinge. So just to show that you can always make something that will fit your needs a lot more easier.
Yeah. Sweet.
That's this week's.
Yeah, it's always interesting to see anything TPU and then like squishing it and like running it over with your car or whatever. And like it's indestructible, sort of, and yet you can still cut it with like scissors and
that is actually what I did for the button cutouts. I just let it print like a 0.5 millimeter thick mold for this, and then just went in there with a hobby knife and cut it out.
Okay.
Because it would be a lot more easier to do that than have to clean up all of the extrusion, because we do have to turn down the retraction for this, so it is pretty stringy when it comes off the bed.
There are some tolerance things too when you're designing stuff for flexible stuff.
Yeah,
like you almost want to have
a little bit smaller,
a little bit tighter. So the idea is that the material will stretch to fit over whatever you're trying to fit.
Exactly. So yep, that is this week's Shop Talk.
It's like a negative value as opposed to a positive clearance. You're looking at a negative offset. Cool.
All right, let's go ahead and jump into this week's Community Makes. This week's Timelapse Tuesday is this really cool Millennium Falcon, which they've renamed as a Memory Falcon, since it is a USB, SD card, any type of memory holder. So you can see the time lapse here. I did have the temperature a little bit higher than I should have. This is the Hatchbox gray filament, so I think like the standard is around like 185, 190 for this. I just had a little bit higher just because of the time lapse, and as you can see, it does, the tolerance wise, it's really good at holding a lot of the USB memory sticks, SD cards. I think the only thing that's missing is like a what is it, CF card holder.
CF compact flash.
And I really like the detail that was in this.
I like the blurry. I like the blur.
Of course. There we go. You can see like the cockpit here.
Yeah.
Chewie and Han would be.
Are they really in there?
No. It's where they would be.
Can you go as close as you can? Let's go all the way in. Let's microscope this closer.
Whoa.
There you go. There's freaking chairs in there?
Some chairs in there.
Oh my goodness.
Hey, look.
Look at those chunky layer lines, folks.
I can get you can see a console there.
Holy moly.
But there is a ton of slots all over. Like even in the front here, you can add like an USB memory stick on that. You have them all on the sides. So there is a ton of room to...
Oh my god, my color temperature is going all over the place.
I know, it's the gray.
There we go. It's the gray, as I used to say.
Yeah, it is.
All right,
but yeah, excellent little... Oh, yeah, and the bottom here, too.
Everything fell off.
I have all the feet and all the turrets and all that stuff on there. Nice detail. Good timing with the opening of Hollywood Studios, which we will not go to.
I was going to say, like,
we're not going to Disney for like a year or something.
Yeah, ever.
Yeah, excellent. But excellent little reminder of not being able to go to the parks.
Oh, really? Okay.
No, it's a great little way to store.
We never did make it to Smuggler's Run, unfortunately.
I know.
We did get to see it. We could have went on the single rider line, but just didn't make it. I'll always remember the popcorn that I ate there. It was like sweet and spicy popcorn at Galaxy's Edge.
Of course, some nice commentary on here from Bruce and Melissa. How fast will that USB drive make the Kessel run?
How many parsecs? Yeah.
Parsecs refers to distance rather than time.
That's right.
So yeah, put the link to this excellent print. It does take quite a while though, and you can see here.
There it is.
Designed by IdRatherBeMaking. Did an
That's
excellent
there's some
weathering
weathering
effect.
as well.
Yeah,
That's
I really
very
like the way
cool.
that came out.
Printed on Ender.
Pretty cool. Yeah, so the
video as well.
tolerances should be pretty perfect for any of the cruelties.
Probe. E-Sun filament. Oh, I love photos when folks are getting their paints and things in there. It's really cool. I have to check out the video.
Yeah. Yanni saying add LED to it. Yeah, that's a really good idea.
Yeah, that'd be neat.
Sweet. Like chop it like right down
It
the center.
It could be a cool sort of USB hub of sorts, like a wall charger. Maybe charge some devices and things. That'd be neat too.
All right.
Ideas.
Post the link to that.
Sure.
And that's this week's Community Makes.
Let's see what else.
I think that's it.
Yeah, that's it, man. We're
I get back
that's
to
a full hour, huh? Sweet.
filling out this Learn guide and publishing this out later today, hopefully before Ask an Engineer.
Yeah,
which,
I got a
nice
lot of
little
files
segue into the rest of the shows coming on later tonight.
Yeah, we invite you folks to come on and share your projects, whether it's work in progress, final stuff, workshops, retro tech, all this fair game. We love to see it, and we hope you join us at 7 p.m. tonight. That's the show and tell show. You can join by hanging out in the Discord chat room in the live broadcast channel, and a link to the StreamYard session will be posted there about 5 to 10 minutes before 7 p.m. so folks have time to get in there.
And remember, it doesn't have to be 3D printing, electronics. It could just be like a tour of your work area, your workspace, or some projects your kids are working on for home, or of course, projects that are in progress. Always love seeing those.
Yeah,
Come
retro
on.
tech stuff. Stories, do you have any stories?
Yeah.
Campfire stories. And
Always
then
welcome.
Ask an Engineer follows after 7 p.m., starts at 8 p.m. Every Wednesday is Ask Engineer at 8 p.m. Eastern Time. Mar and Phil get some insight on the latest products.
Anything going on
news
in
from
the factory.
New York.
Lots of secret projects that are being worked on.
Right.
And more.
More. The Desk of Lady Ada is returning, and we might be seeing some more, what do you call it, like
Some more
regularly
hours,
scheduled
yeah.
content. I believe there are some works happening to make that a weekly occurrence. So we might go from random hacker time to more regularly scheduled programming. So stay tuned for that. There was one on Sunday that happened where Lamar was replacing some stuff for I believe it was like a coffee mug warmer.
Yeah.
She replaced a part and used DigiKey search to check that out. It was about a half-hour stream, so check it out if you want to see some insight on how she uses DigiKey's search engine and just some overall nice engineering.
Yeah.
Check it out. John Park has 2 shows. He starts it off with Tuesdays at 3 p.m. He does a full hour of Make Code Live. So if you'd like the block-based code editor, you can check out Make Code Live with John Park. And then,
like he was doing some Matrix projects inside of MakeCode, so definitely check that out.
Excellent. And then he has a second show, John Park's Workshop, on Thursdays, every Thursday at 4 p.m. Eastern Time. We also have Scott, who does a Friday live stream.
Yeah.
I still don't have the thing, so I'll just... What's it good to... I'll just say go to Discord.
Need to have Bruce.
I know, I need to have a
our
graphic.
Designer Bruce.
Yeah.
Make a
Deep dive
with
with Scott.
Yeah.
So maybe like a little icon where he's like
Diving
diving
into
in or
code.
something. Yeah. He puts his like ski or his cap on with the goggles. He gets in there. He does a deep dive every Friday at oh boy. Somebody help me out with the
Somebody just put.
yeah. What is it? Question mark showtimes.
Yeah.
And that's a great way to get the full list in Discord. Our little Dino bot will tell us deep dives are 5 p.m. Eastern Time Fridays. I was confused because he says 2 p.m. PT time, because that's his time zone. He's up there in Seattle.
All right, and you guys have been watching at 3D Hangouts. This happens every Wednesday.
Does it? Yeah. And again, we had a power outage. Today it's sunny, so
It's too bright out.
it's too bright. Yeah. Hopefully we don't have a sunny thing. All right, well, that's going to be it for the show. Don't forget, we're going to do show and tell tonight, as well as Ask an Engineer will be tuning in. And don't forget, next week, we got the CircuitPython meeting happens every Monday, so we start off all nice and cheerful.
And as a reminder, these shows are archived, so you can subscribe, get notification when they are posted up there. So people was asking that in the YouTube chat. So, yep, don't forget to subscribe, like, and all that.
And we appreciate your orders. Don't forget, AdaBox is shipping still. It's
yeah, right now I think all the seats are full, but you can definitely get a notification if we have any openings. You definitely don't want to miss this one. Lots of cool projects in the works for it.
All right.
All right, until later tonight.
Remember to stay safe and
Stay safe and
make a great day.
Yep.
All right, bye, folks.
See you tonight, folks.